Welcome to my YouTube channel. In today's video, we are going to discuss bagging, a powerful and simple learning technique in machine learning. Let's dive into the concept with the help of this illustrative image. Let's understand what is bagging. Bagging, short for bootstrap aggregating, is an ensembled learning technique designed to improve the stability, accuracy of machine learning algorithms. It reduces variance and helps to avoid overfitting by combining the results of multiple models. The core idea is to train multiple classifiers on different subsets of the training data and aggregate their predictions. So what is overfitting? Overfitting basically when the algorithm learns the data too much. And understanding the image now. The image depicts the bagging process, showcasing its key steps, bootstrapping, training multiple classifiers, and aggregating their results to form an ensemble classifier. The first original data. At the top, we have the original dataset represented by a collection of multicolored dots. This dataset is a starting point for the bagging process. Bootstrapping in, is the second step. Bootstrapping involves creating multiple subsets of the original data through random sampling with replacement. Each subset is represented by a different group of colored dots, may contain duplicate instances, and will be of the same size as the original dataset. Third is the training multiple classifiers. Each of these bootstrapped subsets is used to train a separate classifier. These classifiers can be the same type, for example, decision trees. In this image, the subsets are fed into different classifiers, and each classifier learns a model from its respective subset of data. The fourth one is aggregating. Once the classifiers are trained, the next step is to aggregate their predictions. The aggregation can be done using various methods, such as voting for classification tasks or averaging for the regression task. The image shows the classifier's predictions being combined to form an assemble classifier. The fifth point is bagging. The final ensemble classifier is created by combining the outputs of all the individual classifiers. This ensemble approach typically results in a more robust and accurate model compared to any single classifier. The ensemble classifier in the image is the result of aggregating the predictions of the individual classifier, providing a final prediction that leverages the strength of each model. So now let's understand what are the advantages of bagging. The first one is that it reduces variance. Bagging helps to reduce the variance of the model by averaging out the errors of the individual models. This results in more stable and reliable predictions. Preventing overfitting by training multiple classifiers on different subsets of data. Bagging prevents overfitting to the noise in the training data, especially useful for high variance models like decision trees, which we saw in the previous video. Third one is that it improves accuracy. The aggregated predictions of multiple classifiers are often more accurate than the predictions of a single model, making bagging a powerful technique for enhancing model performance. So what's the conclusion? Bagging is a simple yet effective and simple learning technique that leverages the power of multiple models to improve predictions, accuracy, and stability. By understanding and implementing bagging, you can enhance the performance of your machine learning model and achieve better results. Thank you for watching the video. If you found this video helpful, please give it a thumbs up and subscribe to my YouTube channel for more such data science and machine learning content. Thank you.